So in the last video, I finished off saying just as with predicates, there are more specific flavors of suppliers. Now there's Boolean supplier, double supplier, int supplier, and also long supplier. So let's actually look at an example. And let's just say that we want to print out the last name of all the employees in the list. And we can use the for each method, so let's do it that way first. So I'm going to start with employees dot for each. Then we're going to do employee arrow token and set up a code block or open a code block, and we'll do string last name is equal to employee dot get name dot substring, and it's going to be employee dot get name dot index of, in a single quote, a space +1. Then we're going to do a printout of the last name that we've extracted with a label before it that says last name is plus last name. So here we're actually finding the first space in the name and then using the substring method to assign everything after it to last name. And we then print out the last name. So we just try running that to confirm it works first. And you can see we've got our last names working okay there. Now if this was something we wanted to frequently do, we would probably add a get last name method to the employee class, but we'll pretend that we don't want to do it for some reason. However, let's pretend that there are several places in our application where we need to get the last name of a single employee. And we want to use a Lambda expression that maps to one of the java.util.function interfaces. Now, none of the interfaces we've looked at so far matches what we want to do. Consumer doesn't return a value, supplier doesn't accept any parameters, and predicate only returns true or false. So we want to actually pass in a string, and we then expect a string to be returned. And this sounds like a job for the function interface. Now, the interface represents a function that takes one parameter and returns a value. The functional method, the one that we use with lambdas, is the apply method. So first let's create the lambda we're going to use and assign it to a variable, and then we'll continue from there. And let's just remove or comment out the other for each statements that we've been using here and some of this other code as well. We don't need a lot of this anymore. So I'm just going to comment a lot of this out. Like so. I'll comment that out. And actually I'll start typing up here above the initial list setup of our employees. All right, so we're going to be setting up this function interface. So we're going to type in function employee string within a diamond, and we're going to call it get last name equals, and the parameters for our lambda are going to be employee, always going to be employee, arrow token and code block, and we're going to return employee dot get name dot substrings, just what we've typed above it basically, and it's going to be employee dot get name dot index of, and the space between single quotes +1, and then we'll finish off our line. So a couple of things to note with what we've just done here. So first, we use generics with function. The first type is the argument type, which in this case would be an employee. The second type is the return type, which will be a string. Also, we need the curly braces around the return statement, even though there's only one statement. And if you recall previously from this section, that when we return a value, the curly braces are always required. But having said that, for lambda expressions that are a single statement and return a value, we don't have to use the return keyword, it's implied. Alright, so right now this function doesn't actually do anything. To get the last name of an employee, we have to call the apply method and pass it to the employee object. So let's go ahead and actually do that and see what happens. We're going to get the last name of the second employee in the list. I'm going to type in string last name is equal to get last name dot apply, and it's going to be employees dot get 1, so we get the second item in our array list. Then let's just print that out as well. Okay, let's just run that and see that it works. And you can see for our second employee, which was up here, Well, actually, that was our third one because I accidentally typed 2, so I'll change that to 1. We should get me this time when I run that because I was the second one that was added. We get my surname, so that's working okay. Now, we could have just created a regular old method called getLastName. Also, as with other Lambda expressions, we could also use an anonymous class. But by using function, we can pass code that accepts and returns a value to a method in the form of a Lambda expression and then run that code without having to create an interface and a class that implements the interface. So as we've seen previously, we can change what a method does based on the function we pass in. So let's suppose that sometimes we want the first name of an employee and other times we want the last name. So we could write separate getFirstName and getLastName methods, but let's do it with one method instead. So first we're going to create a function for getting the first name. So it's going to be function employee string getFirstName is equal to, and the parameter is going to be employee again, arrow token and a code block. Then we're going to return employee dot get name plus, dot substring. But this time we're going to do 0 and employee dot get name dot index of, and we're looking for a space again. So this time we're starting from the start of the string up until we find the first space, so we're getting the first name instead of the last name. And we'll finish off that definition for our function. So now we're going to add a method that accepts a function employee string argument. So I'm actually going to delete this just to free up a bit of space, so we can see what we're doing. So let's add that function down here, or method I should say. So private static string get a name. This time the parameter is going to be function employee string get name employee. Then we're just going to return get name dot apply employee. Alright, so now we're going to add some code to the main method that gets the first or the last name of each employee. So we're going to do random1 equals new random. And we're going to do for employee using for each employees. Then we're going to do if random1 dot next boolean. So if that returns true, we're going to actually get the first name. So we're going to do print out, and it's going to be get a name. Then the parameter will be get first name, and the second parameter is going to be employee, the one that we're currently processing. Then put an else in here, else if the random1.next boolean returned false, we're going to do get a name again. But this time we're going to pass the get last name function that we created, and employee we still need to process. Right, I'm just going to comment out that other printout we had there. So let's actually run this and see that it works. So you can see that in some cases we're getting surnames, but Snow is obviously a first name, Red is a first name. And we run this again, we should get random results each time. You can see we're clearly getting different results each time. Now, in a more complex application, there may well be cases where we want to run similar code for a set of situations. We may have, say, 30 lines of code we want to run, and only 2 lines of code will vary depending on the situation. Now, rather than using interfaces with methods that are called at the appropriate points, or writing different methods for every situation, we can actually pass in functions for the parts that vary. That way the code will be more concise and easier to follow. Another situation in which functions are useful is when we want to use callbacks. So let's say that we're fetching data in a background thread, and when the data is ready, we want to massage it in some way on the background thread, and the specifics of what we want to do can vary. So we want to be able to specify the what code to run when the data has been fetched. Now, there are a number of ways that we could do this. Java provides ways to notify threads and run code when a background task is completed, but we can also use functions. So let's actually just say that we're fetching a bunch of images from the internet, and when we have them, we want to resize them all. The thread that started the background thread is responsible for providing the code that will do the resizing. So we could do it the following way, and what I'm going to do is I'm going to paste in some code because we're not going to actually run this, but we're going to just discuss one possible way of doing it. Now this isn't a complete code sample and we can't run it, but we can discuss what it does. The thread that wants images fetched in the background would have to provide an instance of a class that implements resizeImage. When the background thread has the images, it would call the runWhenDone method and use a provided instance to resize the images. Now there are different resizing algorithms, and the one we want to use may change depending on the current load of the system. So the requirements, quality versus file size, and other factors. We have to create a resize image implementation for every algorithm, or we could use functions and do the following. So I'm just going to paste in a bit more code here. Now that we've done it this way, there's no need to write an interface and a bunch of classes that then implement that interface. We can create a function for each algorithm we may want to use. Now once again, using lambdas reduces the amount of code we need to write, and in this particular case would make the code easier to follow. Now rather than having a bunch of classes, each with a resizeImage method, we can actually define all the functions in one place. Anytime we need to use a callback, meaning that we want to run code when a specific non-user interface event occurs, using a function is one option to consider. So hopefully at this point you're beginning to see the power of using lambdas with functions. So imagine that you want to transform an object in some way, and the transformation requires 4 steps. For each step, there are several different algorithms you may want to run, and which one to run will depend on the state of the application at the time or on the object that will be transformed. So let's suppose that there are 3 possible algorithms for step 1, 2 for step 2, 5 for step 3, and 3 for step 4. So that's a possible 3 times 2 times 5 times 3 equals 90 variations. How would we do this using interfaces in a way that wouldn't be unwieldy and require us to write lots of implementing classes? Using functions instead would result in less code, and the code would also be easier to read. All we'd really have to do is write a method that accepts 4 functions and then write the 13 functions we may need to use. When we want to transform an object, we'd pass in the appropriate function for each step. So I don't know about you, but to me that sounds easier and a lot more readable. This is really the power and convenience of using lambda expressions. Alright, so I'm going to finish the video here now. In the next video we're going to continue on, and we're going to work a bit more using functions in our employee code. So I'll see you in the next video.